Okay, so today we're going to be doing serial dilution, and that means we're going to be creating a dilution from one initial stock solution of 20%, and we're going to be diluting it down in increments. So we've decided to dilute it down from 20% down to 10%, 5%, and 2.5%. To do that, we will be using the serial dilution equation, where concentration 1 times volume 1 is equal to concentration 2 times volume 2. That means we'll be finding the correct volume of water to add to the stock solution in order to dilute it down to the desired concentration.
This is a picture of a meniscus. A meniscus occurs when there is a more attractive force between the container and the liquid than there is between the individual liquid molecules. You read a meniscus from the bottom when looking at the liquid at eye level.
At the beginning of the video, we introduced the dilution equation of concentration 1 times volume 1 equals concentration 2 times volume 2. Given in the original equation is the initial concentration of a 20% stock solution times a volume of 5 milliliters equal to the final concentration of 10% times an unknown volume. Using simple algebra, we find the final volume for the 10% concentration would be 10 milliliters. Since the original solution already has a volume of 5 milliliters, we take the difference in final and initial volumes and add 5 milliliters of blue water to create a 10 milliliter solution at 10% concentration. Using a graduated pipette, 5 milliliters were taken from the 10% concentration to repeat the same equation and process for the 5% concentration and again for the 2.5% concentration as shown in the video above. Before the experiment began, the mass of each beaker used was measured. The mass of each concentration was taken at 5 milliliters, and then the mass of the beaker was subtracted from the overall mass of the beaker and solution. The resulting difference in mass was used to calculate the density, or mass divided by volume, of each sugar solution. The resulting density was used to plot the graph shown in the results section of this video. As explained earlier in the video, our given experiment should use 25 milliliter volumetric flasks. However, due to an equipment limitation in the laboratory, we opted for 25 milliliter beakers instead.
In the next section, we will discuss the results of our procedure. Here are images of our calculations. We analyze this data to present our results. Our results. After the procedure was completed and the data collected, we decided to analyze this data by graphing it. We plotted each data point into the graph and created a density versus concentration graph. We created this graph in order to observe the relationship between concentration and density. As shown in the graph, as the concentration increases, density also increases exponentially.